Page 11, example 35.2. This example, you have 4 energy terms given. They are formation of sodium hydrogen carbonate, formation of sodium carbonate, formation of water, and formation of CO2. And then you need to find out the standard enthalpy change of this reaction. But from 1 to 4, you have no equations, so you better first write down the corresponding equations. For example, the formation of sodium hydrogen carbonate is 1 mole of sodium hydrogen carbonate is formed from its constituent elements under standard conditions: sodium, H2, carbon, and oxygen. And the half hydrogen and 3/2 oxygen at the physical stage. And the corresponding delta H is negative 94.7. Okay. And then the next one is formation of sodium carbonate. It is 1 mole sodium carbonate formed from its constituent elements Na, carbon, and oxygen. Sodium is solid at room conditions, but oxygen is gas, carbon graphite. The most stable state of carbon is graphite, not diamond. Mixture 1 in front of sodium carbonate, and delta H is negative 1131. And water is 1 mole water formed from elements hydrogen and oxygen, and half oxygen is required. Lastly, it is carbon dioxide. Carbon dioxide formed from elements graphite and oxygen. 1 CO2 require 1 C and 1 O2. Negative 393.5. Okay, now 1, 2, 3, 4 equation, and then the problem is sodium hydrogen carbonate, water, and CO2 unknown. And then I see that sodium hydrogen carbonate only occur in equation 1. Sodium carbonate only equation 2. Water equation 3. CO2 equation 4. So I think I will add equation 1 on left hand side, 2, 3, 4 on right hand side, and then draw a enthalpy cycle. Okay, I add the sodium hydrogen carbonate first. 2 times equation, two times the energy, okay, or delta HF sodium hydrogen carbonate 2 times, and then the equation 2, it is 2Na, 1C, and 3/2 oxygen, and the water and CO2 remain unchanged, and energy is negative 1131 one time only. Actually, it is equal to delta H formation of Na2CO3. Water is coming from hydrogen and oxygen. So Na keep no change, carbon no change, and the water is H2 and half O2. 1.5 and 0.5 equal to 2, and 1 it is negative, or it is equal to formation of water lastly CO2. For the CO2 you can see that 2Na, okay, hydrogen, and then 2C here, 1C and 1 CO2. So 1C and 1 O2 is needed. Two C change to 1C means one of the C change to CO2. And 1C require 1 O2. 2 O2 is remain unchanged. And one of the O2 go to the one of the C, forming CO2. It is the delta H formation of CO2. And then the delta H path 1 on the left hand side, path 1. And then the right hand side, path 2. And the delta H of this reaction, ROX reaction, ROX stands for reaction, is minus this term. Okay, and it is delta HCO2 formation of CO2, and it is the formation of water, and it is the formation of sodium carbonate, and it is the formation of hydrogen carbonate, and you can see that the CO2, formation of CO2, formation of water, formation of sodium carbonate, they are reactants. Sum of the delta H formation of reactants minus delta H formation of, it is the products. Delta H formation product carbon dioxide, product water, product sodium carbonate, minus reactants formation. And because there are two here, you need to have 2 times of formation of sodium hydrogen carbonate. And from the book, okay, you can have the numerical values are the negative 1131 sodium carbonate, water and CO2, minus 2 times of reactant sodium hydrogen carbonate. And you can use the formula summation delta H formation of products minus summation of formation of reactants. When the equation has coefficient 2, you need to multiply with 2 times. And this equation is over here. Okay.